Okay, yeah, welcome to my talk, Secret Management with HashiCorp Vault. Just so you know if you're on the right talk, the focus of this talk is to talk a little bit about secret management and why you would need secret management. This is kind of very brief. The talk in the noon did actually a good job to do that. And afterwards, I will talk about what is Vault and how can it help you with your secret management. And at the very end, I will talk about some Vault internals that are really interesting. The goal of this talk is think about some practices in your company that you could probably improve on, and ideally go and play with Vault. And disclaimer, so I'm not connected to HashiCorp. I like the product, so it's kind of a product presentation, but I'm not connected to HashiCorp or Vault or whatsoever. So why do I focus on Vault? It has, as far as I know, an unmatched feature set without having a vendor or framework login. And it's mostly open source. There are some enterprise features, but in all the projects where we used Vault right now, we never had to use the enterprise edition. So with the open source edition, you can mostly do everything. Other solutions in the same space, if you look for something like that, and disclaimer, I haven't used any of those actively. I just read the documentations or played around with them briefly, is Kiwis from Square. It doesn't have as many features. It doesn't have so-called dynamic secrets. I will talk about dynamic secrets later. Big plus, it has HSM, like hardware security module support in the open source version. There's GitHub from Cloud Foundry. That looks very promising. I think it has dynamic secrets. I didn't completely understand the documentation. However, it's tailored and very specific to Cloud Foundry. That's kind of a minus. Cloud Foundry is really for big companies. And then there's the AWS Secrets Manager, which is kind of 1 year old. They have not dynamic secrets, but something similar. You can extend it with Lambda functions. It looks very promising, but of course, it's a little bit AWS-centric. And of course, you can do everything yourself, but that's a lot of complexity and work. So secret management, what is secret management? I think secret management is not something that everybody would define in the same way. So what I mean when I talk about secret management is, so secret management is part of your security concept. And one focus of secret management is internal threats. That can be rogue employees or unauthorized access to secrets. With that, I mean, I'm a developer of App 1, but because we don't have any process in place in the company, I have probably access to secrets to the database of another application, for example. It's long-living secrets. Like, I create a new application, I create a database, somebody creates a user with the passwords, and from then on, the credentials are valid for months or years, or actually probably forever, unless there's a security problem or breach when we have to roll our secrets. Part of secret management as well for me, like how I would define it, is audit log. Like, I have a log where I can see who requested credentials for which system at what point of time. That's very important if you have some compliance requirements. And it's part of secret management as well is high automation for changing, revoking, and rolling secrets. And well, that should be everybody should know about that, and that's super clear. High entropy of passwords. But it doesn't always happen. So we had a project half a year ago where we created a Kubernetes cluster, and we came back a few months later, and they created a database on AWS, which was publicly available in the internet, and the password for the production database was secret1 exclamation mark. So I think everybody knows that this is necessary, but it's not always the case, unfortunately. I was always looking for this extreme example where a company was going bankrupt because secrets were out in the open and were long-living. And actually, Sam Newman today, that was what I was looking for. So there was a company where the passwords were out in the open and it was destroyed within 50 minutes, and they could never, they never got back their data. So what is the current situation in secret management? So the best practices are actually widely known, like high entropy in password, etc. And they're usually seen as very important. So you will never get the answer from somebody, from a manager, from nobody, do you think secret management is important? Nobody will ever say, no, it's not important. However, implementation is hard and solutions are pretty rare. Furthermore, like apps and frameworks are mostly not ready for modern secret management. What I mean with that, this is what the talk is about. And high automation is actually still an exception if you talk about like smaller to medium-based companies. Like bigger companies, they usually have secret management in place, but it's usually very complex workflows which slow down the companies. And this is like opposed to external threat mitigations like firewalling and keeping your operating system up to date, keeping your Docker images up to date. That's usually automated, but secret management is very often not automated yet. And it's often, that's why it's often neglected in favor of critical features, business features. So one question for the room, like who here has production credentials on their laptop at this very moment? Can be database passwords, SSH keys? So little. Okay, better. So who thinks that is a good idea? Hopefully nobody, right? So why am I talking about secret management? So quickly about me, I'm a senior consultant at innoQ in part-time. I'm focusing on DevOps and continuous delivery topics. innoQ is a company that does consulting, architecture consulting, code reviews and architecture reviews, and hands-on development as well. There was a talk previously, like before this slot, where Stefan Tilkov was talking about the company. If you're interested, we have a very interesting company culture. We meet each other like 6 times a year. It's a great company. Okay, end of advertisements. So a typical project where I'm usually come into, it's like, it's a migration from a monolith to a microservice or self-contained system architecture. The language is, a lot of times it's already set. It's mostly Java with Spring Boot. Data center is usually, for us, it's AWS or on-premise. Container management these days is always Kubernetes. We don't even get the question anymore if that's the right solution or not. And then CI, whatever you used before, it's mostly Jenkins, and please use something like GitLab or even something like Conquer CI. Logging, everybody knows about logging. It's usually, I don't know. It's usually Elasticsearch and Kibana, and monitoring is something new. Not everybody knows about this. This is like usually Prometheus. Secret management is something they usually don't know about that. And most of the times they don't know what I really mean with secret management. The question I ask is like, how do you inject the password for a database to your applications? And usually the answer is like via environment variables, which is like the 12-factor app way to do that. And when they're on Kubernetes, it's like reading values from secrets. This is all nice. Then the next step is like, okay, so how do you make sure that not everybody can read every secret from every application? If they're good, the answer is like we have like role-based access control in Kubernetes all figured out, which is usually not true, but sometimes they do say that. But now here, this like the next points. Usually, I've never seen any project or company that had that figured out. Like changing passwords for applications is usually a manual process. Audit log is something nobody actually really has most of the time. And usually they can really say who has access or who has credentials to which databases. If an employee with knowledge of a lot of credentials leaves the company, passwords are usually not changed. And revoking credentials is something most of the people don't really support. So, and all those examples are completely tailored to Vault, of course. Like, Vault can help you with all those problems. Like the executive summary, this is the marketing speech from the webpage. So I'll be really quick. It secures, stores, and tightly controls tokens, password, certificates, API keys, and other secrets. And it handles leasing, key revocation, key rolling, and auditing. And for all this, it provides actually a nice REST API for all those operations. So it's really easy to use. And just to be sure, because people mix it up, this is not meant to sit in your request response file of your application. So Vault is not there to do user management of your application that you deploy, but it's meant for your applications to get access to the surrounding systems. So in its easiest way, like Vault looks like this. You authenticate and authorize somehow. And then there's this thing in the middle, which is like this Vault process with the REST API. And on the other end, Vault gives you secrets. If this was the only thing it does, you just changed one set of secrets against another set of secrets and wouldn't win a lot here. But Vault can actually provide several methods of authenticating. Some are suitable for humans, like LDAP or username and password, and some are usable for like applications that run in Kubernetes on AWS. And on the other side, you cannot only store like static values like API keys that you write in and then you can get out again, but you can get like so-called dynamic secrets, which is what I will talk about now. So dynamic secrets, what are they? They are like on-the-fly created credentials. That's why it's called dynamic, for each instance of an app or a user who wants a secret. So if you have a web shop and you do a new deployment and you have 10 instances, every instance of your application will have an individual user and an individual password to access the database. And all those secrets, they have a time to live. So they are only valid for, let's say, an hour or a day, whatever you configure. And all this is fully audited. So you can always say, like, I deployed version 5 of my application last Thursday at 2 o'clock, and on host with IP address, this instance got access to database 2, for example. And how does this work? So it works like the thing that Vault does is it automates the work that usually operators do for you. So in order to create a new user, because it creates users on the fly, you need to have admin credentials in order to be allowed to do that. So the first thing that you do if you configure such a secret, a dynamic secret backend, is that you provide Vault with credentials that allow you to create new users on the fly. The second point, that's only if it's necessary, that depends on the backend. You configure Vault with settings that tell Vault how to create a user. I will have an example. This is probably kind of confusing. In the third step, because we have like short-lived secrets, sometimes you have to tell Vault as well how to delete those users again. So let's stay with the example of a MySQL database, because that's something that, any relational database, that's a very common use case. So in the first step, I configure Vault with credentials to be able to create users on my MySQL database. So you have a little bit of code. So I configure it to be, okay, this is a MySQL database, and you access it with this user and password. So in this case, I call it admin and password. And this is the host of the database. And there's 2 roles that I will later create. And one of them is called client read-only, and one of them is called client read-write. Because some applications probably only need read-only access, and some do need read-write access. So first step, you configure the credentials, and the second step, you configure those roles. And in the relational database case, this is like, so here we have the client's read-only database. And we say, okay, use the database named client, that's the database I configured up here. And the creation statement, and this is now like simple SQL code. It's a mini template where name and password is like random strings that get filled in by Vault upon creation. And this is like SQL code, right? Create user identified by the password and grant select on clients. And the read-write role would be the same, but instead of grant select, it would be grant select, update, insert, delete on clients to this user. And then we have default TTL, like this. These secrets are only valid for 1 hour. In some secrets, like this is what we configured here now, you can extend the validity of the secrets, and we can do it like a maximum for 10 days, like 240 times. I could say, please let this be valid for more time. But after 240 hours, in this case, we would have to get new secrets from Vault. So once I've configured that, now I have an application. In this case, I assume, like in all those examples, I assume that the application is authenticated and authorized to talk to Vault. So it reads from this magic path here. Why this is a path, I will explain later. Like read DB credentials clients read only, that's the role I configured earlier. Then Vault will create a user on the fly in the MySQL database and return the login and the password to the application. When our TTL is over and we didn't renew the credentials, Vault will automatically delete this user from the database. So even if somebody gets the username and the password, after 1 hour in our example here, it's not valid anymore. So if the person leaves the company, cannot do anything with it. So for the database backends, there's support for quite a few databases here, not only MySQL. You can use it for the most common candidates. Another secret backends, which is interesting if you live in the AWS world, is like talking to the AWS API in order to create a new EC2 instance or delete a new EC2 instance. The strategy is always the same. So the very first step is to provide Vault with the credentials in order to be allowed to create an IAM user or SDS token. Then you create the roles. I left this step out here. Then an application can read from AWS creates def. That's the role that I created here. Vault will then talk to the API and create the token or the IAM user. In the case, if that is a token, like AWS supports TTL token from itself. So whenever there's a backend system that supports TTL, Vault will use that feature. And they are returned to the application, and then the application can talk to the API with that. And again, if it's not a token but an IAM user, Vault will then delete the IAM user when the TTL is over. Private key infrastructure. That's interesting if you want to do like secure traffic in your cluster, like mutual TLS. Authentication. Configuration step is again the same. You provide the CA certificate and the CA private key to Vault. Then an application talks to Vault. Vault creates a client certificate, and the application can use this client certificate to talk to your applications. So with that, we actually implemented mutual TLS in our Kubernetes cluster. These days, you would do that probably with Istio or Linkerd 2.0. But at the point when we used that, those service meshes weren't available yet. You can use Vault to give developers access via SSH to hosts. There's 2 methods. First method is that you talk to the wrong button. You talk to the Vault API and tell it, okay, please give me access to this IP. And Vault creates a username and a one-time password on the fly. With that, you can try to connect to the host. And now on the host, there's a small Vault agent that talks to Vault and validates this username with a one-time password is valid, and then gives you access to the host. The disadvantage of this technique is that if they cannot talk, you don't have access to your machines anymore. So there's another technique, which is harder to draw. That's why I only have text. Basically, in a nutshell, is that you sign your SSH public keys with a Vault CA and use this signed public key to connect to another host. And on this host, the SSH daemon checks whether this public key was signed. This is actually not used very often in SSH, but it's a core SSH feature. So that is supported by the SSH daemon. It's the better technique, but a little bit more complex to explain. And then finally, the last secret backend I want to talk about is Transit. So if you want to encrypt or decrypt documents without storing anything in Vault, Vault got you covered there as well. You just actually have to activate the Transit backend, and then you can just post a document to Vault, and Vault will return the encrypted document. And the application on startup can then call the endpoint with decrypt and gets the document back decrypted. So sometimes this is necessary. I don't know of a good example currently, but yeah, you can just use it as a decrypt and encrypt facility. The good thing here is that the private key for de and encrypting doesn't leave Vault, so you don't have to care about to store this private key somewhere. It's all handled by Vault. Okay, so there are more secret backends. We have talked about most of them. There's Consul, if you work with Consul. There's RabbitMQ, and a few others. There are probably a few new ones now. But of course, not everybody who has access to Vault should be able to read all the secrets that we have. So we have to authenticate somehow against Vault. And they are called auth backends. And Vault has quite a few of them. Some suitable for developers and some suitable for applications. Before we go to the authentication backend, I will talk about tokens. Tokens are actually the only way to authorize against Vault, and they are always created by Vault, so you cannot create a token yourself. And they are returned when you authenticated successfully. So authentication, you provide a username and password. Vault checks somehow, okay, username and password are correct, but that doesn't tell you what you are allowed to do. That is authorization. They're kind of comparable to a session ID on a website, if you live in the web. And they always have permissions and policies assigned to it. So a token always have permissions and policies assigned to them. So a token can say, for example, this developer can read can get a password for the database read-write access or not. This is how you can create a token. This is a command with a Vault CLI client. You never use this command, but just to show like what a token looks like. It's kind of like a UUID. There's a token accessor. I would skip this for now, what this means. The duration of this token is 5 minutes, so every token has a TTL. It's renewable, and the token policies, I'll talk about policies later, the default is always applied, so you can just have some rights or policies always that every token should have, and in this case, admin as well, so you can have several policies applied to it. So for developers, you can use external identity providers. This is a little bit like an auth 2 flow, but it's a little bit different as well. And the first one is like LDAP, Radius, or Okta auth. They all work the same, basically. You have to configure Vault to have access to LDAP. And then what I do as a developer, I log into Vault with the auth method LDAP. What Vault then does, it forwards these credentials to LDAP, and usually, like if username and password is correct, the response contains, first of all, the user and the groups the user is part of. And depending on this two information, Vault will create a token with those policies applied to it. So it could be like, if I'm user Kesselborn, I will get the policy admin because I'm an administrator of Vault. Oh yeah, and then I can use the token to talk to the Vault API. The same, like if you live in GitHub, if you have user management in GitHub, you can do this. It's basically the same. Instead of username and password, it's a token. Instead of groups, it's teams. But the strategy is the same. For applications, so now we're back to the questions like, how do I get a password for a database to my application without storing it in my Git repository? And the first backend I want to talk about is Kubernetes auth for people who use Kubernetes. If you don't know Kubernetes, every pod, if you don't know what a pod is, just think of containers. Every container in Kubernetes is run with a technical user, which they call a service account. And every service account has a token with which it can authenticate against the Kubernetes API. That can actually, just authentication, it can mean that it cannot do any operation on the API, but it can always authenticate. It can always say, okay, this service account, yeah, it's valid, it's the service account. This, by the way, as well, if you live in Kubernetes, for every application, you should always create a service account with no permissions whatsoever, unless you want to talk to the Kubernetes API, which is usually not the case. So what you can do now, if you are in an application, you can authenticate against Vault with the method Kubernetes, and you pass on this token. Oh yeah, sorry, I forgot. Like this, the token for the service account is mounted in every container that runs in Kubernetes. So on every container, you can read this token. What you can do now, if you want to talk to Vault, you can read this token and then say to Vault, log in with the method Kubernetes. Vault passes this on to the Kubernetes API. And if this is a valid token, the response has something like the service account name and the namespace of the service account. And depending on those two information, Vault can then create a token with certain permissions and policies attached to it. So you map from the service account name and the namespace and all the namespace, you map that to tokens. And then you can use this token to talk to Vault. So just because Kubernetes is quite popular, that's how we did it in a project. So we had an init container that did all this authentication dance here and got this token and saved it in shared volume. Then the init container, like if that was successful, the init container dies and the app can just take the token up and talk to Vault. And this init container was just a bash script because Vault is a REST API. You can just do everything with curl. You can use console template as well. Console template, if anybody knows that from console, that can directly talk to Vault as well. But this was a super simple container. It was an Alpine Linux with bash. If you are not on Kubernetes yet, but you run on AWS, there's something called AWS auth, and gives you the same possibility. You can run applications without injecting secrets yourself. And what you basically do, you have your EC2 instance where your applications run on, and you have the EC2 API. And on every application, we have this EC2 metadata service available. So that means basically on every EC2 application instance in AWS, if you're not familiar with it, you can curl informations about your own instance under this URL here. And AWS provides an encrypted version of the instance identity document at this path. So it's on every instance, it's this path. And this is encrypted by a private key from AWS. So what you can do, you curl this document, you get this document, you pass this document onto Vault and say, log in with the auth method, AWS auth. First of all, Vault checks whether this was really encrypted by AWS because, of course, the public keys are well known. So it knows, okay, authenticated, check. And then it talks to the EC2 API and verifies that this instance should be allowed to have access to Vault. And this depends on there's quite a few characteristics you can check on, like AMI ID, account ID, VPC subnet ID, IAM role, instance profile. So there's quite a few characteristics you can check on. And then based on that, you create a token. And with this token, oh yeah, 0.8, I forgot that one. So you create a token, and then optionally, but you should always do that, you blacklist this instance. The idea here is that you can do this authentication like everybody or every application that has access to this EC2 instance can authenticate itself to Vault with this method. So what you do, the idea here is like early in the boot process, you do this authentication with a small daemon or application. And after that, this instance is blacklisted and nobody else on this instance can do it again. So even if your instance is hacked, you cannot authenticate again with this instance. And finally, you use this token to talk to Vault and then get whatever secrets you want. There's another method called IAM auth method. This is a lot more complex. I just have that in here for reference. App role, I won't talk about this in detail now. The slides I provide, they have some graphics about that. It's the same idea if you don't use AWS or Kubernetes, but Marathon Mesos or just Chef or Puppet, you can actually do the same using app role. It's a little bit more complex, but it's manageable. So in the end, you use whatever auth you want and get access to systems. So what we did as developers, or actually we have it in the company currently as well, you authenticate yourself with LDAP, and then you get policies that give you access to the AWS API, to databases, to the private key infrastructure. We use that, for example, to get access to Kubernetes. If you use kubectl or kubectl, however you want to pronounce it, that actually works with a client certificate. You have client certificate authentication. So in our internal cluster and For another project, we did the same. You authenticate with LDAP, you get a client certificate, you write the kube control config, and then the developer has access to Kubernetes for, let's say, a day or something. So once a day you have to log in, you get Kubernetes. Somebody leaves the company, you don't need to worry about your Kubernetes access because it's not valid anymore. And to SSH machines. And then again, the applications that run in Kubernetes, they authenticate with the method Kubernetes to Vault and then get access to databases, static secrets like API keys, certificates as well, and probably decrypt some stuff that is encrypted in the repository. So quick look at policies, and for that we have to know that Kubernetes, not Kubernetes, Vault, we're in the Vault. Kubernetes organizes secrets like a file tree. And for static secrets, like let's say API keys, that's very straightforward because this is like static stuff. So you have some organization here, team, app1, API keys, Google Analytics, and PayPal API keys, for example. But this is the case to the outside for everything. That's why, if you remember some Vault commands earlier, it was always like looked like a file path. So if I want to read files for data, like want to read secrets for database access, I do Vault read /database/creds/clients read only, and I get back username and password. Although this is dynamic, so every request will return a different user and a different password. And the policies now, they apply to files or directories, if you want to stick with the file tree metaphor. And they support file system wildcard. That's why it's quite handy. They support what the user can access, and they get assigned after authentication, and they are always bound to a token. And the policy bound to a token cannot be changed. So instead, you need to create a new token. And those are the usual suspects here: create, read, update, delete, list, deny. I think everybody can probably understand what they mean. There's a special permission called sudo, because there are some paths in Vault which should only be accessible to admin users. That's, for example, like switching on and off the audit log can be done via the REST API as well. And that should only be accessible by admin users. So this is like how a policy looks like. For an application, this application is allowed to list and read every static secret under secrets team 1 app. Furthermore, it can get a client certificate by accessing, can issue a client certificate by accessing PKI issue broker. And it can read, can get read-only credentials for a database. Okay, the audit log. The audit log is surprisingly off by default, but that has a good reason. So you have like 3 supported backends, file, syslog, and socket. And if Vault cannot write the audit log, it will not respond to any request. The idea is that somebody who wants to do something malicious could just fill up the hard disk, then Vault cannot write the audit log, then does the malicious stuff, and then frees up the database. So for you, it would look like the audit log is intact. But yeah, Vault just doesn't do anything if it cannot write the audit log. And the audit log logs every operation, and it logs like what was done, when it was executed, by who it was executed, and then the request payload and the response payload. And of course, like the sensitive data is not like printed in the logs, but it's hashed using HMAC SHA-256. And the idea here is like if somebody twitters out your database password and you realize that one day later, if you know the content of the payload, you can hash it with the same method and then search in your logs and see who created the password, for example. So this is like an example log. We can see, okay, the username, that's me. I authenticated via LDAP. The operation was I tried to list all the secrets, and the permission was denied. And the hashed value of my client token for Vault that I used was this. So I have a pretty nice audit log for everything. Yeah, before I come to internals, like small recap, you authenticate somehow, you get policies attached, and then you can read static or dynamic secrets, and everything is locked. And Vault is this thing in the middle here. So some interesting internals to Vault. The storage. Vault doesn't bring its own storage engine. It can use several storage engines. The most common ones are Consul and etcd. Like in the Kubernetes world, a lot of people use etcd. Consul is from HashiCorp as well, so that's very well supported as well. But there's a lot of other options. Just be careful, not every option supports high availability mode from Vault. The data is encrypted at rest with a symmetric key. And this symmetric key is encrypted by a master key and stored on the storage backend. And this master key is encrypted with something that is called Shamir's secret sharing. So you have to decrypt the master key in order to decrypt the symmetric key. And this Shamir secret sharing is a super interesting technique. And it means that in order to decrypt the data, you need 1 to n keys. And when you want to decrypt the data, you can provide those decryption keys in any order. So there's no order to it. And you can create more keys than you need in order to decrypt the data. So to make it more concrete, like Vault, when you initialize Vault, it creates 5 keys on initialization, this is only done once. And 3 of those 5 keys are needed in order to unseal Vault. And this is configurable. You can as well create 10 keys and 8 are necessary. You can create 15 keys, but only 5 keys are necessary, whatever fits your company. And the idea here is that you have high availability of key holders. Because every time you start a Vault instance, and if you have high availability mode, you could have 5 instances of Vault, for example. Every time you start an instance, you have to decrypt the master key. So that is per instance, not per storage backend. And as one key alone is completely worthless, like the key holder doesn't have to be somebody with some special access and contracts. It can be everybody, designers, ops, devs, team assistants, whatever. You just want to have high availability of key holders. If somebody who has one of those unsealing, they are called unsealing keys, leaves the company, you can create new keys. Like if you have 5 keys in those 5 keys in Vault, somebody leaves the company, and then you need 3 keys in order to create 5 new keys that you can redistribute, and the old keys are all invalid after that. And I already said that, like every time a Vault instance is started, the master key has to be decrypted. Vault high availability. Actually left out the slides, but I'm good in time. So high availability is like you have, like, for example, 3 instances, but only 1 instance will answer to request. If the request goes to one of the passive instances, there's a redirect, like a HTTP 302, to the leader of the cluster. So what about Vault usage? Like Vault integration, like there are some frameworks who have integration for Vault. Spring Boot has some support. I don't know how good it is. We always had to do some work on our own, for example, for the dynamic secrets. And if you do it yourself, I think the best way to do it is to create, like, stick with the framework. Usually the frameworks, they read config files with the credentials. Like, stick to this technique and create config files with a helper application that talks to Vault. So you can use console template or a bash file for that. And that way, like, local development doesn't have to change. You don't have all this Vault logic in your application, but you have a small helper for that. And they are really easy to write. We did it with a bash script. You have to prepare your application to TTL credentials. So your applications has to react accordingly when your database password is not valid anymore. What you have to do, you have to reread the configuration files, which ideally, of course, has the new credentials already written in them, and then redo the database request. or if you are in a container managed world and your front router will retry the request. If it fails, you can just exit with an error code, and then the container management system restarts your container. But that kind of depends on your setup. How do I get started? There's kind of like really a 1-minute invest. You go to this URL, vaultproject.io/demo, or #demo. And that's like an interactive vault that gets set up to you. You can initialize Vault, unseal it. In this example, though, I think you only need one key. You can write secret and read secret just to get a feel like how it feels like to work with Vault. The next step would be to download it locally and start with the --dev parameter. That starts Vault and stores everything in memory. And the investment for that is like 20 minutes to get it running, and then you play around with it for a few hours or a few days to get a feeling with it. However, there is a really steep learning curve. So there's a lot of different backends. So we already talked about like secret backends, auth backends, and storage backends. And then you have all the surrounding services. And all those services use the same word, and they usually have a slightly different meaning. And in the first weeks, it was always like, okay, we have this certificate and this certificate, it's TTL, this is a token, oh no, it's this other kind of token. So there's a lot of complexity, actually. And getting started is kind of hard. And it's hard to really test something quickly, because if you want to test, this AWS authentication thing in order to get some MySQL password for your database, you have to have access to AWS, you have to have a user that is allowed to create other users. You have to have AWS set up there, and you have a MySQL database, and you have to configure all the roles. So it's not like that you try it out and in the first 3 minutes you have a good example working. So it's kind of hard to start. And then if you're already familiar with Vault, so you mastered all that, and if you want to bring it into productions, like nearly every tutorial only runs in this development mode, where you don't need HTTPS, you don't need certificates, and all this stuff. So bringing it into production is quite some work as well. So there is quite an investment. And with that, I'm actually finished. Thank you.